Predictive maintenance. When we speak about predictive methods, machine learning, and really big cases for industry, predictive maintenance is for sure on the top numbers listed for any kind of cases. Still, what is it? And I have to admit, it's damn difficult, predictive maintenance, in my opinion. So let's have first a look on the maintenance maturity models, because you have to go through these models typically step by step. So the first one is reactive. Okay, something breaks down and then you have a reactive maintenance. And this happens, of course, still quite often. And normally, if this happens more often, you are also on a lower level of the overall equipment efficiency. Remember, we had discussions on overall equipment efficiency. This kind of breakdowns can happen, and this is always an indication that you are also operating on the lower range on overall equipment efficiencies. The most classical one are so-called planned maintenance, planned scheduled maintenance activities. So, for example, if you think about your car, that would be a classical planned scheduled maintenance after a certain amount of time or after a certain amount of mileage. Kilometers, you have to go to your maintenance schedule. Fair enough, you can really prevent there a lot of failures, and that's the most classical part. If you go into this kind of proactive maintenance, we are more in the root cause topics, which we had discussed before. So you really try to figure out what is happening there and go towards the root cause, and you lift your overall equipment efficiencies quite a lot. And then the predictive maintenance, normally also associated to the highest level of overall equipment efficiency, is really when you predict into the future, which is in the first hand quite simple to understand. The techniques behind are always around machine learning techniques, and in this paper here linked here, there are several techniques from a machine learning perspective listed. And if you go into the internet and if you search for the internet, you find always cases towards predictive maintenance. And this is, for example, the most classical case. You have a machine and you go to the sensors, and the sensors have vibrations, and these vibrations show a typical behavior, and then you go towards this curve. So at the beginning everything looks fine, and then you're going down the vibrations more and more. It pops up in weeks and days, and suddenly it breaks down. And I think the overall cases you can find are always going into this direction. I have to admit, whenever I had this kind of cases, the time between occurring of maybe a noise output and the breakdown was really short, and then you have really a big challenge to find the correct spot when really the breakdown will happen, because at the end you have to decide for the maintenance cycle. Yeah, you don't have a fixed planned maintenance window, so depending on the status of the machine, you really judge on this maintenance cycle, and here's the challenge really starts. And here's one source which claims they are doing, and of course there are a lot of papers around. This paper I liked quite good, because in fact, if you speak about predictive maintenance, it's a lot of topics you have to learn from your analytics perspective. Number one, you really need a very good understand of the overall problem. So for example, this PF curve, so it's a potential versus functional failure. So degradation starts somewhere, and then you have a potential failure and finally a failure, and this kind of time spans, these can vary like hell. In the paper itself, they show also some real numbers and real curves, how they try to detect it. And normally, if you look on these curves, they always show really an ugly behavior in the background. From a really technical perspective, you really have to set up your entire data modeling and your entire tool stack in a perfect way. It is not about only the predictive part itself. It's really, we discussed this in the OEE part already, it's really about capturing all data assets you really can use towards this predictive maintenance. It's not that you typically only go with some sensor data. It's really you have to embed many things around. It might be on the type of the product you are just producing. It might be really only on the sensor data. And you have to capture the right granularity of the problem. Think about this. If you have sensors in your machines, sensors can really produce a lot of stuff. And I calculated once the amount of sensors only for a car, how much sensors are in a car. And if you would track all kind of sensor signals in the car to do the predictive maintenance inside a car, you would see that normally this is just too much and a lot of noise, because sensors are producing the signal in milliseconds. Do you really predict on milliseconds, or do you want to predict something into the days? Then a resolution of milliseconds does not make any sense, because you have to do the abstraction. Once you do the abstraction and you want to predict something into the days, you lose maybe the granularity. So you have to go really good feature engineering. And the feature engineering part of this entire predictive maintenance, I think it's really important that you archive all this information for your machine learning algorithms. I can recommend also from my old group, and I think Max, hello, maybe you see the lecture, they have really done a fantastic job on GitHub itself, where they wrote a package how to extract all the information for the features then for predictive maintenance. So here you can see the link of the very good Python package, how to do this feature engineering. In summary, to predict a failure, it's really something we all want, because then we can do the better scheduling on top. But someone on top has to define, okay, when are we doing this maintenance cycle? And the risk associated to this is really challenging, because who would take the risk that a really expensive machine is maybe not maintained now in this window because you think it's everything fine and you rely on the data sets itself? So sometimes it's really a balance between technical possibilities and really implementing it in your organization, that you really go towards this predictive. Still, it's an absolute future topic for every kind of production line or already produced engine. This will be also the future for many things, and you should go there step by step over the OEE cycle towards then really predicting it. It's really also for data science a lot of fun to go into this kind of projects, because you really have to combine from data engineering towards process engineering, towards machine learning models, towards visualization and everything. It's really a fantastic use case. And some of these use cases are really big. If you can solve these problems for your machine park, you are for sure a hero in your company. Go there step by step, and don't hunt too fast into the predictive algorithms itself. You will see only spurious correlations in the data sets if you start with the sensors directly. But maybe you have to do your own experience, and maybe for some machines I'm also wrong that it's really simple to do this kind of predictive analytics. Good luck.